Hi everyone, welcome back to the eCoreAcademy e-learning platform. My name is AJay, back with yet another Algebra 1 video for you all. And today's lesson topic, we're going to be covering linear equations and specifically writing in standard form. Now before we jump into today's video, please make sure to do 4 things. Please make sure to smash that subscribe button down below, hit that like button on this video, turn on post notifications, and feel free to leave a comment down below giving us any feedback and also suggestions for future videos. So today we're going to be covering standard form, one of our major linear equation forms. We've already covered slope-intercept form, personally what I think is the basis of linear equations and their equational formats. And then of course we covered point-slope form, and now we're on to our third and final linear equation form, standard form. So what exactly does standard form look like? Well, it looks like this equation right in front of me. It's ax plus by equals c. So as you can see, the structure of this equation is fairly simple. Your variables are going to be your x and your y. As always in linear equations, unless you have a 3D or essentially a 3-variable system, which we're not going to be focusing on in Algebra 1. Later on in Algebra 2, you'll see that come about. But for linear equations and just about any other basic formatted equation within Algebra 1, you're going to have an x and a y in your equation. And then, of course, there's 3 unique new terms that we're essentially seeing here. That's going to be your a, b, and c, and those are all going to be constants, meaning they're going to be integer values. So the standard form, what is the purpose of standard form? Well, standard form basically allows you to find both the y and x intercepts of a linear graph. When you're looking at a graph, you can easily identify through standard form to actually start graphing the graph itself by graphing 2 major points. And then, of course, you can shift to slope-intercept form to calculate the slope. Or you can merely identify this equation from a graph fairly easily with the intercepts. And this equation, just like the other 2, point-slope and slope-intercept, can be altered into slope-intercept form. So you can always alter this into slope-intercept form, and you can also change this back into point-slope form, vice versa between all of the equations. If you aren't looking for intercepts of a graph, always switch to the other forms for their specialized purposes. This really helps when you're focusing on intercepts. Otherwise, you might want to use, solely your slope-intercept form or your point-slope form. Point-slope form meaning using specific points on a graph to actually discover what your slope might be in that case, or using slope-intercept form, which actually helps you graph the actual graph by using information from your slope-intercept equation. Alright, so what is this basic structure of standard form? So standard form is structured in ax plus by equals c. And in this equation, a, b, and c are all integer values, and neither a nor b can ever be equal to 0. So that means a and b, your 2 consistent values that are being multiplied to your x and your y, they can never be equal to 0 because then they'll change the values of the x and y to make them always equal to 0. But c can be equal to 0, it's its own constant term. However, a and b are merely integer values, but they're still being multiplied to your variables. So in this case, on the left-hand side, we have 5x plus 4y equals 10. That's a linear equation written in standard form. We see that 5x plus 4y, obviously your a is consistent there. It's not 0, it's 5. And then, of course, 4, that's not 0 either. That's your b value. 10, it can be any number like, it just has to be an integer. So in this case, 5x plus 4y equals 10, that is a valid standard form equation. However, on the right-hand side, we see that 5x equals 7. Well, we're missing the entirety of b and, of course, the y variable here. And in that manner, that would not make this a suitable equation. This would not be an existent equation in this case, and that would definitely not be proper standard form. So now let's talk about moving from slope-intercept form to standard form. So we're given the slope-intercept form equation, y equals 2/3 x minus 5, and now we're tasked with moving it into standard form. So the first thing that you're going to do is, let's rewrite this big and bold here. Y equals 2/3 x minus 5. Now, keep in mind, the first thing that we want to do is we always want to keep the x and the y both on the one side, our left-hand side, and keep our constant on the right-hand side. So the first thing that we're going to do, of course, is to move across our 2/3 x to the other side. So now we're left with negative 2/3 x plus y. equals negative 5. And now the last step to do here is, remember, A, B, and C have to always be integers in this case, so therefore they cannot be fractions or decimals. So what we must do here is we must multiply this whole entire equation, keeping it balanced. We have to multiply it by 3 in order to get rid of this fraction, negative 2/3 being multiplied to x. So we're going to multiply both sides of the equation by 3. So on this left-hand side, we get negative 2x plus 3y. And then on the right-hand side, we get negative 15. And this, of course, is our finalized standard form equation. All right, so now let's look at point slope to standard form, our other linear equation. Excuse me. So we have y minus 4 equals negative 7/2 x minus 2. So remember, like I said, you always want to keep your x value on the left-hand side. But the first thing that we're going to do here is, in order to simplify matters so that we don't multiply out a fraction to our x minus 2 and making it harder, we're first going to clear out the fraction of negative 7/2. So let's rewrite this here. So we're going to multiply both sides by 2 in order to clear out that fraction of negative 7/2, and we're left with 2y minus 8 equals negative 7 times x minus 2. And then, of course, we can go and simply, carry out the distributive property and distribute negative 7 to x and negative 2. So we get that 2y minus 8 equals negative 7x plus 14. And then, of course, we want to always keep our x and our y consistent, our ax and our by on one side, and then, of course, our constant on the other side. So we're going to move negative 7x to the left-hand side, and then we're going to move negative 8 to the right-hand side. So negative 7x is going to the left-hand side. So 7x plus 2y is what remains on the left-hand side. And that will obviously equal, we're going to add 8 to both sides of this equation, and we get that 14 plus 8 is 22. So 7x plus 2y equals 22. Our a value is going to be 7, our b value is going to be 2, and our c value is 22. All right, now moving on. So now what we're going to focus on is the actual concept of creating your equation from a graph. So you can take this from a simple graph, or oftentimes you're going to be given an x-intercept and a y-intercept of a graph. So when you're given the y-intercept or x-intercept of a graph, or both of them, obviously in this case, we're given 7, 0 as our x-intercept and 0, 3 as our y-intercept. You can merely plug in those values for your a and b values. It's as simple as that. So for your x-intercept, you can plug in for your a, 7, and then of course for your y-intercept, it's going to be 3 for your y. And that's easy way to tell is because you're multiplying your a to your x, so that's going to be your x-intercept, and of course your b to your y, so b is going to be your y-intercept. And then of course the constant is going to be determined by the specific graph that you're given, and that, of course, if you think about it in terms of regular slope-intercept form equation, it has to do with altering your y-intercept essentially, because you are multiplying out in order to clear the fractions and also to clear your slope in order to create your separate x and y on one side, and then of course your constant without any of them being decimals, all of them being integers. Alright everyone, so that'll be it for today's video. Fairly short video, just getting through the standard form. But the next couple videos are going to be progressively getting a lot longer, lengthier, but also a lot more information. They're going to be getting a lot more complex. We just built the fundamentals of our linear equation, something that we wanted to keep very simple for you all and break them apart into bite-sized chunks for you all. So now that we're through linear equations, we have the basis of these linear equations, we can start to look at more advanced formats of our linear equations and our graphs, and actually look at real-world problems and word problems and concepts. So that'll be it for today's lesson. This has been the eCoreAcademy e-learning platform. Please make sure to like and subscribe down below. Check out our website at www.ecoreacademy.org. We have the entire unlocked access to what we offer as a course to you all. We have note sheets, quizzes, and worksheets for all of you to access through the actual website that go along with each and every single one of our videos to help you better understand these concepts. Also, email us at eCoreAcademy@gmail.com if you have any questions or if you just want to reach out. And check out all of our socials in the description box down below at Pinterest, Facebook, Twitter, Instagram, and also TikTok. See what kind of interesting content we have there, and also use those mediums to share all of our videos to those who might need help or to those who might find them interesting. Alright everyone, so this has been AJ Raj here at the eCoreAcademy e-learning platform. I hope you guys enjoyed this video, and I'll see you guys in the next one. Peace.